Math 3 Unit 5 practice test. This first part is asking which sampling method is used. I'm not going to read them. I'm just going to go ahead and give you the answers. For number 1, it is random. Number 2, it is convenience. Number 3 is systematic. For 4 and 5, they are asking you what is the best type of study. And again, I'm just going to give you the answers. Number 4 is observational. And number 5 is controlled experiment. Number 6 asks you to find the standard deviation for the set of data. This right here means they've already gone through the whole process of finding the mean, subtracting your original set of data from the mean, and adding them all up together. In order to get your variance, and remember that is the symbol for variance, you have to take this number, which is 360, and divide it by how many data pieces that you have. This right here tells us how many data pieces we have. And so 360 divided by 15 is 24. In order to then find the standard deviation, and that's our symbol for standard deviation, you need to take the square root of that number. And so we have the square root of 24, and you can put that into your calculator and find the answer. But for your test, this one question, they don't have the decimal answer, and this is also not an answer. But what they have done is they have broken 24 down and simplified the square root. And so we know that 6 times 4 is 24, 6 is 3 times 2, and 4 is 2 times 2. And so we have a pair of 2's, and we have a 3 and a 2 left over. And so when you end up simplifying that, your pair of 2's gets to be brought out, and then you multiply anything that's left over, which is 6. And so this would be the answer you would end up choosing for this problem. On all other problems, when it's not a multiple choice, you can just write the decimal answer. All right. Okay, number 7. Number 7 asks us to find the variance and standard deviation for this data. In order to do that, you first are going to find the mean, and when you find the mean, you add up all of these numbers. So we're adding up 8 plus 13 plus 15 plus 19 plus 20. And again, you can use your calculators, and you add all those up together, and you get 75. In order, though, to find the mean, you have to divide by how many pieces of data you have. And if you count here, we have 1, 2, 3, 4, 5. 5 pieces of data. And 75 divided by 5 is 15. So the next thing we do is we write each of our pieces of data. So we have 8, 13, 15, 19, and 20. All of these have the same mean, which is 15. Next, we subtract our data piece with our mean. And so 8 minus 15 is negative 7. 13 minus 15 is negative 2. 15 minus 15 is 0. 19 minus 15 is 4. And 20 minus 15 is 5. Next, we square all of those. Negative 7 squared is 49. Negative 2 squared is 4. 0 squared is 0. 4 squared is 16. 5 squared is 25. Now, in order to find our variance, we have to add all of these up together. Again, we'll use our calculator, add those up, and you should get 94. In order to find your variance, though, remember that you're taking that number and you're dividing it by how many pieces of data we have here. And again, just as before, we have 5 pieces of data. And 94 divided by 5 is 18.8. In order to find the standard deviation, we take the square root of 18.8, and that is approximately equal to 4.34 when you round it to the nearest hundredth. Okay, number 8 says, given the following 5-number summary, answer the following questions. They tell you that n equals 23. That means that is the number of pieces of data that you have. Okay, and so the question is there an element in the data that must have the value of 7? So is the median a value in the data set? The easiest way to find this is by taking your n value, which is 23, and you divide that by 2, which equals 11.5. Because it's 11.5, we round that, and it means that the 12th number is the median. So 7 is a piece of data in the data set. So my answer is yes. And there's a couple ways of answering this, but I'm going to say it this way right now. There is an odd number of data pieces, comma, so the 12th number is the median. Now, had we had 24 numbers, 24 divided by 2 is 12, and so the median for that would be the average between 12 and 13, and then in that case, the answer would be no, it's not an element of the data. Number 9, given the following 5-number summary, are there any outliers? So in order to find outliers, you have to start by finding your IQR, and your IQR is Q3 minus Q1. In this case, our Q3 is 35 minus 25, which is 10. Once you have the IQR, you take that number 10 and you multiply it by 1.5. You will multiply it always by 1.5. It's just one of the rules for finding outliers. And so we go 10 times 1.5, which equals 15. For your lower boundary now, you take your Q1 value, which is 25, and you subtract 15, which makes 10. For your upper boundary, you take your Q3, which is 35, and you add 15, and that equals 50. So to check if there are outliers, you would need a number that is smaller than 10, and if the minimum value is 20, there are no numbers that are smaller than 10. So there is no outlier for the lower boundary. For the upper boundary, if you have any numbers greater than 50, that would be an outlier. And here the max is 68, which means that there has to be an outlier. So the answer is yes, 68 is an outlier because 68 is greater than 50, which is the upper boundary. Number 10. Suppose the Dollar Depot currently sells 385 distinct items that cost between 75 cents and $1.50. They now decide to sell an item that costs $3. Select whether the value of each statistic for the prices of the items at the Dollar Depot increases, decreases, stays the same, or cannot be determined. So for the mean, talking about your average, if all of the amounts are this, and then all of a sudden you add something in that costs $3, that is going to increase your mean. Your median, we do not know what all the 385 numbers are. So if we listed out all 385, the median is your middle. We have no idea what it is when you add in this $3, and so we cannot determine the median. For the mode is talking about what number shows up the most. Now they're only adding in one $3 item, and so whatever the most item was, the mode, it is going to stay the same because whatever showed up the most is still going to show up the most. All we're adding in is a $3 value item. Now the standard deviation is talking about the average distance between each number. If you add in a $3 with this, it is going to increase your standard deviation because your spread is now going to change because you've added in something that is much greater. Okay, moving on now to number 11. So for number 11, we have this data set. It says use the data above to create a 5-number summary. Okay, if you look here, everything is in order from least to greatest. So we're going to go ahead and number our data. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 pieces of data. Our minimum value is here, which is the least, which is 19. Our maximum value is up here, which is 78. In order to find the median, we take our number, which is 10, and 10 divided by 2 is 5. So my median is between the 5th and 6th numbers. So this is where my median is going to be. So in order to get that, we have to take the average. So we are going to take 37 plus 44, and we add those together, and we get 81. And 81 divided by 2 is 40.5. So my median is 40.5. To find Q1 and Q3, you would take the amount of data that you have on one side, and if you look here, there are 5 data pieces, okay? And so we take 5 divided by 2, which is 2.5, and since it's at 2.5, we would round that up to 3. And so my third number is my Q1. So right here, this is Q1. It's in the middle of this half set of data, okay? And that number is 32. Now to find Q3, we're gonna count over from the median. So starting at the median, but not including that median value of 4.5, you count over 3. 1, 2, 3. And so the 8th number, 45, that is Q3. Next, they asked us to determine the IQR, lower boundary, upper boundary, and if there are any outliers. Okay, and we already practiced this once here previously on number 10. And so we're gonna start by finding the IQR. And so the IQR is Q3 minus Q1, and in this case we have 45 minus 32, which is 13. So that is my IQR. Now in order to find our lower boundary and our upper boundary, we first have to take our IQR and multiply that by 1.5, and 13 times 1.5 is 19.5. To find your lower boundary, you take 32 and you subtract it by the 19.5. When you do that, 32 minus 19.5 is 12.5. So that is my lower boundary. The upper boundary, you take 45 and you add the 19.5. And when we do that, we end up getting 64.5. To check if there are outliers, we look for any numbers that are less than 12.5. And since my minimum value is 19, there are no outliers for the lower boundary. For the upper boundary, we're going to look for any values that are greater than 64.5. Our max is 78. So if you look up at your data set, the only number that is greater than 64.5 is 78. And so we have one outlier, which is 78. Okay, so now we're going to make our box and whiskers based on this information. The first thing you need to do is label your x-axis. So you'd count and figure out how many numbers. The way that we're going to do this today is we're going to do these by 10. So I'm going to write out up to 10, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, when you have this, you need to always mark your outliers with an X. And so 78, we're going to say, is about right here. And so I'm going to mark that with an X for my outlier. When you have an outlier, your high number or your low number then changes to the next highest or next lowest number, not including the outlier. So in this case now, my highest number is going to be 56. So 56 is going to be around here. And so that now is going to be my max number. Okay? And then I'm going to mark my Q3, which is at 45. So I'm going to mark 45 is probably about right here. And we're going to mark that as Q3. And then 40.5 is my median. So that's about right here. I'm going to go ahead and put an M for median. And then Q1 is at 32, about right there. And then my minimum value is at 19. Okay, so when you're making your box and whiskers, you always draw a line from your min to Q1 and a line from your Q3 to your max, but not marking it to the outlier. And then you do a box around the Q1 to Q3, and then draw a line for your median. And that is your, sorry, I should have moved that up a little bit, but that is your box and whiskers based on the information we have. Okay, number 12. A boy and girl were discussing the PE mile and their times. The boy ran a time of 365 seconds, and the girl ran a time of 450 seconds. The average time for all the boys at the school is 485. So right now, I'm going to go ahead and write down here boys, and I'm going to write girls. Okay, if we go backwards, it says the boy ran a time. So that is a specific boy, and we're going to go x equals 365 for that boy. A girl ran a time, and we're going to do x because that's a specific girl's time, is 450 seconds. The average time for all boys at the school is 485, and so average is our x bar, which is 485, and that's for all boys. And with a standard deviation of 85 seconds. So standard deviation equals 85. The girls' average time at the school, so again, that's x bar for girls, is 540 seconds with a standard deviation of 70 seconds. Okay, so then it says relative to their gender, who ran faster? Show all the work for full credit. And so whenever we're trying to figure out if something is a better score, we need to find the z-scores based on the data given. So we need to find the z-score for the boys. And so for the boy, the z-score, we're going to do x, which is 365. We're using our formula here, and remember mu and x bar are similar, and we're just dealing with our x bar for our data right now. And so 365 minus 485 divided by 85 will give us the boy's z-score. So z equals 365 minus 485 is negative 120 divided by 85. And negative 20 divided by 85 is rounded to the nearest hundred, negative 1.41. Okay, and so that is the boy's z-score. For the girl now, we're going to find her z-score. And so we go z equals, the score for the girl is 450, minus the mean, which is 540, divided by our standard deviation, which is 70. And 450 minus 540 is negative 90 divided by 70. And negative 90 divided by 70, rounded to the nearest hundredth, is negative 1.29. And this is the girl's z-score. When you are dealing with time and running, you have to think about your data. You want the lower z-score, okay? Because that means that you want the lowest score for time, and so the girl has the lowest time in terms of z-scores. So we are going to go ahead and circle girl, okay? And so then we're going to explain. So we would say relative to their gender, the girl ran faster because she had a z-score of negative 1.29, while the boy had a z-score of negative 1.41. So something to that effect. Okay, let's go ahead and move on to number 13, which is our last problem. Okay, 13. 900 juniors at Central City High School took the PSAT score, or PSAT last year. So first of all, I just want us to know N equals 900. There are 900 juniors, 900 people taking the test. It's important to know that number. Okay, it says the scores were distributed normally with a mean, so that's our x bar, of 1,100 and a standard deviation of 100. Okay, label the mean and 3 standard deviations from the mean. Okay, so I always like to mark these so it's easier to see what's going on here. So our mean is 1100. I'm going to go ahead and write 1100 right there. And then going up by 1 standard deviation, we add 100. So I have 1200, 1300, and 1400. And then going backwards, we subtract 100. And so we'd have 900, 800. Oh, sorry. Hold on. 1,000, 900, and then 800. Okay. So also you might want to mark, if it was on your test, just to make sure you understand what's going on. Remember that in the middle your mean is 0 standard deviations. This is 1 standard deviation, 2 and 3, and then going backwards it's -1, -2, and -3. Next, you need to mark your percentages. We know that 68% of the data is within 1 standard deviation, and when you divide that by 2, that makes each of these 34%. Okay, going out, each of these are 13.5%. And then we have 2.35%, and then 0.15%. And you can double check by adding, and all those should always add to be 100%. So this first question A says, what percentage of scores are between 900 and 1200? So we go 900, and then we go to 1200. And if you look up that, we have 13.5 and 34 and 34. And so we're going to add all of those. 13.5 plus 34 plus 34. And when you add all those together, you get 81.5%. So 81.5% of the data is in between 900 and 1200. B, what percentage of scores are higher than 1300? So if we go here and we take everything out, higher than 1300 is the 2.35 and the 0.15. So you would add up 2.35 plus 0.15, and when you add that, you get 2.5%. C says approximately how many juniors? So whenever they're asking you how many of something, you have to take your total number. So I know I'm going to take 900 and I'm going to multiply it by something. And it says approximately how many juniors scored between 1200 and 1400. So here's 1200 and 1400. We need to add up those percentages. Okay, and so we add up those percentages, which is 13.5 plus 2.35. And so again, scores between 1200 and 1400. Okay, 1200 to 1400 is right there. Adding up those two percentages, which equals 16%. Now, when you're multiplying, you can't multiply it by a percent. You have to change the percent to a decimal. And so you'd move the decimal 2 places to the left, and you get 0.16. 900 times 0.16 in your calculator, you end up getting 144, and that is juniors. D then asks approximately how many juniors, so we know we're going to have to take 900, scored lower than 1,000. Okay, and so here's my 1,000 right there. So what percent? We have to first add up those percentages to figure out how many people. And so on this one, we are adding up 0.15 plus 2.35 plus 13.5. And I just realized that I made a mistake when I added these ones up before. And so we're gonna go back here really quick to see when I added those two up, oh my goodness, it's actually 15.85%, if you caught that, good job. And so when you move that 2 decimal places, you actually are taking that and multiplying by 0.1585, which equals 142.65, which we're going to call 143 juniors. Okay, this one though, when we add it all up together, does make the 16%. 900, we move the decimal 2 places, we get 0.16, and then we know that from the previous answer, that was 144 juniors. Okay. E, if Barry Allen had a Z-score of 3 on the PSAT, what is his actual PSAT score? So we know that our Z-score equals the score minus the mean divided by the standard deviation. So in this case, we know the Z-score is 3. We don't know his score, but if we go back and look, we know that the mean is 1100, okay? So we have x minus 1100 divided by our standard deviation, which we know is up there as well, which is 100. In order then to solve for x, we would need to eliminate our fractions. So we're going to multiply both sides by 100. That cancels out. We have 300 equals x minus 1100. To solve for x now, we would add 1100 to both sides. When we do that, we get x equals 1,400 for the PSAT score. Okay, F, if James Jesse scored 900 on the PSAT, what is his z-score? So again, same formula, but this time we know the score, which is 900, and that's like our x value. X equals the 900. So we're going to go 900 minus, we know our mean, again, it's up at the top, is 1,100 divided by our standard deviation, which is 100. 900 minus 1100 is negative 200, and negative 200 divided by 100 ends up equaling negative 2. So on this, the z-score equals negative 2. All right, and then the last question. If the sample has a variance, so we know variance is that symbol, of 6.7, what is the standard deviation? And so in order to find the standard deviation, which is that symbol, we always take the square root of the variance, so the square root of 6.7, and that is approximately equal to 2.59 if you were to put that into your calculator.